Hello everyone, welcome back. In today's video we are going to explore a function that deletes nodes from a linked list data structure based on a given condition. So the delete by condition algorithm or function that we are going to define is a powerful function that gives you a lot of flexibility when managing the linked list data structure. In fact, this algorithm is one of my favorite functions in the series of deletion operation on linked list data structure, because it gives us a lot of flexibility to manage our linked list. Say I want to delete all the even numbers from my linked list, I can do that. Or if I want to delete all the positive numbers or negative numbers, or all the odd numbers, or if I want to delete all the numbers from my linked list greater than 7, or delete all the numbers less than 4. So it gives us a lot of flexibility to filter out our linked list data structure. So first of all, what we are going to do, we are going to define a function that takes a number, and based on the condition we provide, it returns true or false. Say I want to filter out or delete all the even numbers from my linked list. So I'm going to define a function that returns a boolean, say bool. Let's call the function condition we provide. This takes an integer, and based on the condition on integer we provide, it returns true or false. And data, this function just returns return data mod 2 equal to 0. So the condition we provide, if the given data is even number, is going to return true, otherwise it's going to return false. So we are going to start traversing from the head of the linked list and go all the way up to the end of the linked list, and we pass each number to this function and get the result. There is one corner case for this algorithm. If the number that satisfies our condition is happen to be the head number, in this case 2 satisfies the condition, 2 is a positive number, an even number. So we first take care of the numbers that are in the head node that satisfy the condition. We keep deleting all of them until we reach a number that does not satisfy our condition, in this case number 4. So what we are going to do first, in the corner case or a special case, we check if head satisfy our condition. Yes, number 2 satisfy our condition. So what we are going to do, we want to delete this head node and update our head pointer. So we want to make head pointer point to the second node. So this node is deleted. Then again we keep checking until all the head nodes that satisfy the condition are deleted. Again, number 4 is satisfied. If we pass number 4 to our data, our function is going to return true. So this node also satisfy the condition. So we want to delete this node by just updating the head pointer. This time head points to the next node. Once we reach a node that does not satisfy the condition, in this case head is right now head is pointing to node number 3 or node having number 5. We pass 5 to our function. 5 is not an even number, so the function returns false. So what we are going to do, we will maintain a temp pointer here. Using this temp pointer, or the node does not satisfy the condition, we are going to check the next node's data, in this case this node's. We will pass the next node's data and check if it satisfies the condition by saying temp.next, which is this node, dot data, which is this number, and we pass it to our function. Again, it's going to return false. It doesn't satisfy the condition. 7 is not an even number. We just want to increment our temp pointer. Temp comes here. Again, using this temp pointer or temp node, we are going to check the next node's data portion by saying temp.next, which is this node, dot data, which is this number. We pass it to our function. This case 10 is an even number, so the function returns true. What we are going to do, we want to delete this node using this temp pointer. So what we can do is, instead of 400, we want to store number 500 to break or detach this connection and establish a new connection here like this. To do that, where I can get the memory address 500, I can get it from temp.next, which is this node, .next, which is this pointer. So I can get this memory address by calling temp.next.next. So I want to set temp.next, which is this memory address, equal to temp.next, which is this node, .next, which is this memory address 500, .next. This way I can detach this connection, and this node is going to be eligible for garbage collection. So right now my temp points here. Let me get rid of these temps points here, and we deleted this node. We don't have this node anymore. This node is gone. Again, we are going to check using the temp pointer. We are going to check the next node data, which is this node. We will check temp.next.data. We'll pass 55 to our function. In this case, returns false. Let's write code for this algorithm. First, we want to check if our list is empty, if is empty, or if head is equal to null. Empty. We just want to return since there is nothing to delete. Else, first the special case is to take care of all the head nodes and keep deleting all the head nodes until we reach a node that does not satisfy our condition. In this case, to satisfy our condition, we delete it by just updating the head node. For also satisfies, we delete that. So using a while loop, I keep deleting the head nodes while I call my condition here, since it returns true or false, condition function. And for this condition function, it takes integer value. I pass head.data while condition head.data, and also at the same time I check while I have not reached end of the linked list. Suppose all the numbers are even and I keep deleting head numbers, and if I reach end of the linked list and the list becomes empty, I check for that condition also. While head not equal to null, I keep deleting the head nodes by just saying head equal to head dot next. Once I delete the head node or one node from my linked list, I'm gonna decrement the length or the size of the linked list. This way I can delete the head node. Say my head node points to memory address 600. I'll first call the condition while condition head.data, which is 2, I pass it to this condition. 2 modulus 2 equal to 0, this returns true. So this condition is true, and head equal to not null. Yes, head is not equal to not null. Head points to memory address 600. So I go inside the while loop. So I set head equal to head.next. Head.next is memory address 100. So this time head is going to point to next node, and this connection is going to be detached. Once the connection is broken, so the initial head node is not referenced by any pointer, it is going to be eligible for garbage collection, and it will be deleted from our linked list. Again, using while loop, I pass the head.data in my condition head.data, which is 4. 4 is an even number. It returns true, and head not equal to null. No, head is not equal to null. Head this time points to memory address 400. So head comes here. Head is not null. I go inside the while loop. I set head equal to head.next. So head comes here. Head equal to head.next. Head points here right now. This node is not referenced by any pointer. It is eligible for garbage collection, so it will be deleted from our linked list. Right now, head points to number 5. So we again going to pass head.data, which is number 5, to this function. 5 mod 5 equal to 0. No, it is not equal to 0. 5 is not an even number. So we get out of the this special case or the first while loop. We found a node or a first node that does not satisfy our condition. So using this node, we can check the next node's data portion, and if it satisfies, we can delete it. Otherwise, we just increment our pointer. So first of all, we are going to do, we will create a pointer to this new node. Let's call it to new head node temp. I'm gonna call it temp equal to head. So this is our new head here. We want to set a pointer to this head. Let's call it temp. We check the next node of this temp while temp.next or this node is not equal to null. We keep traversing while temp.next not equal to null. We keep traversing and we pass the data portion of each next node to our function if condition of temp.next.data. We don't want to pass the data of the temp pointer, because we already checked and this is the node that doesn't satisfy our condition, so we are going to pass the next node of the temp. So by calling temp.next.data, which is number 7, we pass number 7 to our condition. If it returns true, we are going to delete it, else we just want to update our temp pointer. So in this case 7 doesn't satisfy our condition, we are going to go to the else block, and in the else block we just say temp equal to temp dot next, then and if we found it, we found, and we want to delete it, found the node that satisfy our condition, we want to delete it in the if condition. So let's increment our temp pointer. So next round of loop, temp come here, we check while temp.next not equal to null, no, temp.next is not equal to null, temp.next points to memory address 400. So we are going to check the next node's data and pass it to our function by calling if condition temp.next.data, temp.next, which is this node, and .data, which is number 10, we pass it to our function. Yes, 10 is an even number, so this condition is true. We go inside the if block, and inside the if block we want to set temp.next, which is this pointer, to point to this memory address. I can get this memory address 500 from temp.next.next. Temp.next points to this node, and .next points to this memory address. So I want to set temp.next, this pointer, and the if block temp.next equal to temp.next.next. So we established a new connection. So by calling temp.next.next, this temp node is going to point to memory address 500 this time. This connection is going to be detached, and we established a new connection here. This node is eligible for garbage collection, it will be deleted. So we have a new connection here like this. Again, we are going to check while temp.next not equal to null, no, this time temp.next points to memory address 500, so this condition is true. We go inside the while loop, if condition temp.data.next, temp.data, temp.next.data, temp.next is this node, .data, which is 51, we pass it to our function. It returns false because 51 is not an even number. We increment our temp pointer, temp comes here. Again, while temp.next not equal to null, no, temp.next is 700, it points to memory 700, it is not equal to null. We go inside the while loop, if condition temp.next.data, temp.next, which is this node, .data, which is number 50, this returns true since 50 is even number. We go inside, we found the number to be deleted. We go inside, we set temp.next equal to temp.next.next. So temp.next, which is this pointer, we are going to set it to temp.next, this node, .next, this null pointer. Our temp.next is going to point to null, but before that, if the last node satisfy our condition, if we set temp.next equal to null, we are going to lose this connection and we don't have access to till pointer. Before updating temp.next equal to temp.next.next, what we are going to do, we check for a condition. If the last node satisfy our condition, what we are going to do, we are going to update the till pointer to point to temp. So before deleting each node temp.next.next, we are going to check if here, if temp.next equal to till, if the next node to be deleted is till, we just wanna set temp till equal to temp.next. Oh, sorry, temp, only temp. So we just wanna make till point to temp. So we updated our till pointer. Tills come here. Then we want to set temp.next equal to temp.next.next. So this time temp.next is going to point to temp.next.next, which is null. Temp is going to point to null. This connection is detached and this node is not referenced by anything. It's going to be deleted. Also, in the case of deleting from head, we check after deleting from head if the size of the linked list becomes 0. If this dot len equal to 0. We're gonna check if deleting from head and if all the nodes satisfied our condition and we deleted all the node and the size became 0, we are going to update our tail pointer. Since we don't have any node, tail pointer is going to point to null, tail equal to null. This way we can delete nodes based on a given condition from our linked list. We are left with a linked list having only odd numbers. Let's jump to IDE and write code for this algorithm. So what I'm going to do is first I'm going to define a private, let's call it Boolean condition. It takes in data and returns return data mod 2 equal to 0. If the data is even, it's going to return true, otherwise it is going to return false. Based on anything we want to filter our linked list, we can provide the condition. If we want to delete all the odd numbers, we say if return if data mod 2 not equal to 0. Okay, we can check that also. So next we are going to define our function public void delete by condition. It doesn't accept anything. First we are going to check if our list is empty. If it is empty, we just want to return if this dot head equal to null, we just return. Otherwise we the special case is to check the head nodes, special case, while we're going to call our condition dot head condition, we pass head dot data. While this is true, and we also check while we haven't reached end of the linked list, while head not equal to null, we just update our head equal to head dot next, and we decrement the len. We also check if this dot len equal to 0. If we deleted all the head nodes, we just want to update our tail pointer, this dot tail equal to null. Else, once we deleted all the head nodes satisfying our condition and we got a head node that doesn't satisfy our condition, so what we are going to do, we are going to set a temp pointer to that newly node. So node, let's call it temp equal to head. Then we check while temp dot next not equal to null, we go inside the while loop. We again going to call our function if condition of temp dot next dot data, the data portion of the next node. If that returns true, we are going to delete it by saying temp dot next equal to temp dot next dot next, temp dot next, sorry, equal to temp dot next dot next. Then again we are going to decrement our size len minus minus, but before that we check if the last node satisfy our condition. We are going to check by if temp dot next or the next node to be deleted is equal to tail. If temp dot next equal to tail, we just set this dot tail equal to temp or the current node. Decrement, else we just want to increment our temp pointer, temp equal to temp dot next. I think that's it. Let's check our function. Let's say I have these numbers, say 100. So I want to delete all the even numbers. So list dot delete by condition. We pass the condition to delete all the even numbers. All the even numbers are gone. We have only 1, 3, 5, 61. Let's try to delete all the odd numbers by changing our condition, saying return true if data mod 2 is not equal to 0. So this is going to delete all the odd numbers. Say we want to delete all the numbers greater than 6. We can say return true if data is greater than 6. Yeah, 1 2 3 4 5 6. Say we want to delete all the numbers smaller than 6, we can do that. It's going to give us a lot of flexibility. By changing this function, we can filter out our linked list data structure. Say we want to delete all the numbers from our linked list that are divisible by 10. So we say delete all the numbers that are divisible by 10. It's going to get rid of 100, get rid of 10, 100, 100, and 610, since all these numbers are divisible by 10. This way we can delete a node from linked list data structure based on a given condition. In the next video, we're going to make this function more flexible, so that the user can pass a function here instead of us hard coding the function inside our linked list. So we want to make this delete by condition function accept a delegate or a function from the user, so that the user in the program can provide any condition he want to filter the linked list based on. Thank you guys for watching. Please don't forget to subscribe to Care with Cougar, and see you in the next video. Bye bye.